Hello, in this video we talk about covariance and the variance of sums of random variables. So first, the definition of the covariance is this expression. So the covariance between x and y is expectation of x minus the mean of x times y minus mean of y. So this expression is quite similar as the variance, because if x equals y here, so covariance of x and x equals the variance of x. And if we make expansion of the covariance, so xy, expectation of xy minus mu xy minus mu yx plus mu x mu y. So the result will be exy minus ex times ey. So this is also very like the variance of x, which equals ex squared minus ex squared, right? Here, if x and y equal, so covariance of x and x equals the variance of x, then equals ex squared minus ex the square, right? And the covariance actually measures the linear relationship between x and y, and it satisfies that covariance x and y equals covariance y and x. So here we have seen covariance x equals the variance of x. And for example, also it matches additive property, covariance x1 plus x2 to y equals covariance x1y plus covariance x2y. And generally, covariance x plus y, so the summation of two variables, equals the variance of x plus the variance of y plus 2 covariance between x and y. So if x and y are independent, so which means the covariance between them equals 0. But this is only one way. So if the covariance between x and y is 0, we cannot necessarily get the result that x and y are independent, because the covariance is only measures the linear relationship between the two random variables. So, for example, x and y has second power relationship. For example, x equals y squared. Then their covariance is 0, but they are not independent, right? But if x and y are independent, so we get a variance of x plus y equals the summation of their variance, because the covariance is 0. And this statement also applies to the multiple random case. So next we take a look at example. Calculate the variance of the sum obtained when 10 independent rows of a fair die are made. So each die will get a 1 from these 6 value, right? So if we die 1 time, then we get a 1 or 2 or 3 or 5, 6. But if we die 10 times, so the random number will be the sum of these 10 random numbers. So if we want to calculate this variance of sum of xi because each die is independent from one another. So we can use the variance of sum equals the summation of their variance. And for each variance of one die, because the random number from 1 to 6, they have same probability to get. So their variance can be calculated as a result of 35 by 12. Then we times 10, we'll get the total variance of this number for the summation of 10 independent dies of fair die. And the second example is for the random number ij. If j's toss with head, then we get 1. If j's toss is tail, then we get 0. So this is a binary trial, right? This is a binary 1 or 0, and they have same probability of 50%, 50%. So now the question is, we want to calculate the variance of the number of heads resulting from 10 independent toss of a fair coin. Quite similar as the last example, but this time the random number is, the value is 1 or 0 for each toss. And we want to calculate the variance of the 10 of the sum of such a random number. So this is the random number we want to calculate the variance upon, right? Ij summation from 1 to 10, and each one is independent from one another. Then similarly, we can calculate the variance of each ij first. Then because they are independent from one another, so the variance of this summation, this random variable, is the sum of the variance of this random variable, right? And for this random variable, it's a binary. Random variables variance is p times 1 minus p. So this is of 1 of force. Then we time together for 10 such toss. We'll get the result is 10 of 4. 10 by 4. Thanks for watching.